So, today our first lecture, our course is called Computing Resource in High-Loaded Systems. And we will talk about different systems, different examples for high-loaded systems and for how it works, how it supported by different technologies. What does it mean high-loaded system in general, and so on. So our lectures um, will be divided into three parts. In the first part, we will talk about SDN, software-defined networks, how it works in telecom. Actually, software-defined networks is uh, mm, some no, it is technology where some computational resources is used for solving different telecom tasks. And we talk about this. It will be some lectures in this topic then. We will talk about high-loaded system in general, and actually in big data as a CRM system. And those CRM system, it's systems uh, which collect a lot of information about users, about subscribers, and we have to understand how we will learn which technologies is used for collecting this data, for processing this data, and actually how it works with how to organize infrastructure for these high-loaded systems. And second and third part will be about effectiveness, about uh, energy usage of this system, how to organize computational resources to use less energy, to use less um, mm, to increase um, effectiveness of the system, of computational systems, how it should be organized from one side, what is the criteria of the energy efficiency, I remind this word, energy efficiency, and how it used now in nowadays systems. So it will be three parts of our topic, and according to tasks and what you have to do on this. I think it will be just testing, maybe. So after each part of the lectures, you will complete test, and maybe I think it will be a good idea if during second part we will try to make some tasks connected with um, infrastructure. No, I think we will do three some three practice works. But we'll see. I think it will be a good idea to process it. So first part of lecture it is not connected with practice, so it's just a theoretical material. So we'll start with this. Do you have some question? to me. So we have, okay, if you don't have, great. So what we can start. So actually we have the list of our participants is about 25 people, and now we see that it's just 9 of this. So you can. So we will start. So I see. Just a minute. I will share the screen and start with lecturing. So my name is Maria Skulish. I'm from Kiev Polytechnic Institute. I'm a professor, and then I'm chief of Department Informational Technologies and in telecommunications. It's maybe old version of this my topic. It's the department was renamed. And we will start with first one, the first part. This today lecture is connected with software-defined networks. According to some words about me, maybe you didn't. I see that there is some people from KPI. So we, I start. I graduate from university in 2005. 2005 as Master of Applied Informatics. In 2010, I complete my PhD in the telecommunication systems and networks, and 2019 it was a doctoral degree. So since 29 I'm professor of this. So I have some scholarship, some different teacher prizes, and so on, so on. So I quite uh, um, have quite spread interests, and have make some activities in as in scientific, as in teaching, and maybe works with some um, pupils from Kiev Academy or small Academy of Science. But anyway, so if you uh, according to these lectures, what does it mean, software-defined networks? Actually, maybe 10 years ago, we start to talk about software-defined networks, and it was something like, let's try to um, uh, divide, divide uh, computational processes in networks from data transmission processes. So it is at that time the technologies was actually all this time in 21st century we have very fast increase of density of telecom floors, so data flows in telecom networks, and therefore for scaling the system, it was this idea was to um, scale the system with usage of computational resources. So some mm, uh, computational processes can be divided from from networks, or what does mean computational process? We can, for example, mapping of the floors, so some calculation in telecom networks can be made, can be can be done. Sorry, can be done somewhere outside of the network. So somewhere not at the point, or not on the telecom node. So we can do so it was just an idea, but today maybe if you take some equipment for telecom tasks and so on, and all products propose some solution for software-defined network. So they propose to extend its possibilities, its features, extend with some virtual issues, with some virtual subsystem to for better scaling. So software-defined network, it's emerging architecture that is dynamic, manageable, cost-effective, and adaptable, making it ideal to high bandwidths and dynamical nature of today's place. So it means that using these software-defined networks, we can write programs, we can write some application which make telecom networks more better. It's some application is used for better service in telecom. So with this architecture, decouple data transmission layer, where all flows with data from user to user is transmitted, are transmitted, and in this one layer, it's a data layer, and second one is control network. So the control network, it's elements which somewhere in cloud, somewhere in the computational system, and it proposed to connect, to organize the control of telecom networks somewhere outside of this network, and it also to provide some issues for better service. According to main trends in the information technology development, classic understanding of network that we have special equipment, different channels, lots of transport protocols, lots of protocols for different layers and so on. But all these network functions is provided by network nodes. So it's a traditional network, and actually, for sure, these networks works today also, and it's normally to so it's a usual network. But software-defined networks, they give some extension of these networks. So the traditional network, all tasks is processing, all tasks are processing on some special equipments by, it depends on vendor, on vendor software, and so on. So it is, you have to you have to work only with this. You buy some equipment, some hardware resources, and you have to use it for no, you depend on you depended on its on vendor solution. But from other side, software-defined network propose some flexibility of some independence of vendors. So we will see how it was. So we have satisfying of growing the bandwidth. So we need lots of transmitted resources for transmission. We have to lots of different technology, and this technology have to be integrated into whole system, and we depend on technology always rebuilt. Technology is always fast change technologies is changed very fast, so it increase the cost of the services, because you always have to buy new equipment. And actually, for example, in our institute we have lots of equipment which was maybe very great, good some years ago, but today it is not for using it because it's not, it's too old for using. So it's in telecom we have really fast growing of the requirements to the networks, and therefore, as we have new requirements, we have to propose new solution. There is some classical computing ability. It means that the number of transistors in microchips doubles every year. So it means that actually we why I put here this picture, because we have we have growing growing number of requests. We have growing number of the floors of the services, telecom services, but it still depends on elementary base. Yes, so ability to compute is not growing so fast as our system needs. So therefore we have to find. So therefore was founded these software-defined networks to go out from dependency of just technical solutions, special equipment, and scale system with using some computational resources, some cloud, where we have in cloud some unlimited resources, but we can use these unlimited resources for scaling our computational system. Therefore, we have to propose or have to use some system which make it. According to the networks and how it was at the beginning, it was mainly not software. We have just some just 1% of functionality was software. But today, it's for sure we have very no, it doesn't mean it's not necessary to say that how software is used in our nowadays, but it's it's give us the possibility to find some software solutions, some computational resources somewhere for calculate, compute the forecast. Not very nice slide. Okay, don't. According to how why we can divide and how why this division was done, because as I told, software-defined network, they propose to divide some data transmission layer and control layer. Actually, we, according to, as you know, for transmit, for telecom, we used 7-level model for it's called OC reference model, where we have to from first layer it's physical layer, physical link, data link, network, transport, session, presentation, and application. So it these protocols is used for connection to for I think you know, because you all of you is from ICT technologies. I think connected with ICT technologies and also with telecom networks. So what does it mean? It means that this division was done lots of years ago, but according to main idea was that actually up to 3 or even 2 layers, beginning from third level, all of these protocols, they are connected with software. It's these protocols use software for its network organization. So just physical link and data link, they are connected with exactly with physical transmission, actually data transmission there. And so these two layers stay they are in software-defined networks realize or works in data link. So it's just for transmission. Even network layer, when we have deal with pockets, with IP, ICMP, so these protocols, it's also used for no, it's also used to software якби, processed. This protocols is processed by software, so it can be divided or organized somewhere in dependent on this layer. It's maybe it's how it works the previous one that it means that sender to send something first it's um, how to package the pocket before the transmission. So it maybe this there is step by step take it step by step pocket is handed into each protocols and from up to the physical link, and then transmitted and then up dehanded this. So the receiver obtain the pocket and start to strip hasters of data understanding. No, so it understands headers one by one from so from the opposite sequence. So sender receive package the pocket from 7 to first, so then receiver the package from first to 7. Okay. What about how it works with network? So we have 7 levels, and how deep understand how deeply understand the pockets during transmission on the layer. Actually, I can show. Maybe I can, or not. Just minute. I have not so much time. Much time. So how pockets works in or how pockets migrate or is carried from one point to another point, from one node to another node. Physical layer, it means to transmit, for example, some wave or some light wave or some by depends on network technology link this technology of this link that transmit information. So for example, network hub, just I will. So we have different nodes in networks, and for example, network hub just transmit, retransmit to the next step the physical. So it's understand or it's just see just on physical layer and just to transmit from one environment to another environment. Then it can be used also. We network we have commutator. So commutator it's maybe even network hub. It's just transmitting without changing technology. For example, optical to optical. Also, so some hub it's not change technology. Commutator, it understand what it received, what technology, data link technology was used, for example, Ethernet, so it's commutator on its stays on the so from one side you have one technology, From other side, we have another transmission technology. For example, here can be some local network. There is then maybe the same, also not local network, but with changing, for example, optical, radio wave, and then optical, so different technology. So it is necessary to see the data link headers of the pocket. And just on router, we have to repack or have to process the network protocol, so IP header for for this pocket, and understand where to send to the next, because for commutator we have just changed technology but without changing the route, the path of the pockets. Then router, it's try to send in best site or best link where the pocket will be processed, sent more effectively. So it is necessary to connect to understand network headers. And exactly on these routers, we can use computational resources, because, as I said, physical layer and data link, it is just for transmission. No, it's physical processes. All computational processes with is software-defined network, they can be divided and sent to controllers. So to understand this network header, to understand where should be sent the pocket, we can use controller. It's actually not so correctly, but why not? It's some no some associated from a 7-level model to 3-level model. So as I said, we come to a software-defined network and how it works. Software-defined networks, for example, from on the left part of the picture, we have traditional network where control plan and data plan, they are together on the one node. So it is we have node and this or switch or router, and this router have to solve all tasks what it is necessary. So it is necessary to connect with next have to connect with other nodes to understand the path of the pocket, or which path or which node is more or less downloaded, loaded, not loaded. So it means how how to find great the best path for the pocket. Also, in such network elements can be could be organized different tasks, for example, firewalls or something. If you want to filtrate or indicate some good pockets, bad pockets, or if you want to collect some statistic of telecom networks, because all this should have to be done in traditional networks. In this node, on this node, and also it is the computational resources of this node. It is computational resources of this node are limited by physical characteristic of the node. So we bought the node from the vendor. Vendor organize this node was physical node should have only that resources what it have, no more. And therefore, for example, when I start talk about actually my scientific direction was always connected with quality of service, with how to increase effectiveness of the nodes. And so actually it was and so when I start to talk about this on 20 years ago, we don't have we know that it's necessary to collect monitoring data for the nodes and to understand which path is better, which is not, how maybe it is necessary to change this or that node to make the network works better. But when we didn't have any additional resources, additional computational resources, we have to very limited or bounded network node. Therefore, we have to think what to do and how. And it wasn't traditional network. But as I said, most part of nowadays vendors propose something with software-defined network. Exactly, the main, as I said, the main tasks which can be solved on the network is from one side, it's routing. So to find the best path for the flow, to make this transmission as fast as possible. But it's main thing, it's routing. From other side, we have some additional tasks, for example, filtering or some monitoring, some security tasks. So it's really necessary because we have to how to say to find if we have to make transmission as good as it's possible, and without this division of control plane and data plan, it was not so it wasn't effectively. But software-defined network propose to divide switches, so divide data plan and some control plan. So we organize the network such then, for example, data or floors from with floors with with main no, data flow. So when you send from one computer to another computer, or from you call for somebody, or any usage of a telecom network, you can we talk about floors of the pockets, because today we have pocket networks, so all information is transmitted by network by as a pockets. So all these information pockets, they are circulate on physical network of programmable switch. They are sorry, they are used for transmission, but all tasks which connected with computational tasks, they are divided and use controller of SN controllers. So we have programmable switch, so switch who receive information from controller, how to transmit the floors, and this is used for so this is used for transmission. But what does mean controller machine? Controller machine, it's as you can see, it is actually it's controller. So maybe somewhere we'll see the structure of this controller. But anyway, so controller, it's like some middleware um, resources. This middleware resources is how it used. It used to um, uh, to organize to ask some solution from application. So we have a, application layer. It means that we have some some programs, some modules, some services, which is this services is organized as an application, and maybe in containerized application. We will talk about this later. And so how it works? Flow, for example, new subscriber send some information. This information comes to the router, and router don't know this flow. It's because it's new one for this network. This control infrastructure layer ask controller what to do with this request. This request, it means so we don't know path. So if infrastructure layer don't know path for this request for this pocket, then it is asked from controller layer. Controller layer receive request from the infrastructure layer and send request to some application, for example, for routing application, which is calculate the best path for this request. After this calculation, after this, application is sent back the information to service control layer, and control layer send back information, but not only one node who asked it. Control layer send information to each node on the path of the for this request. So we say new request incoming on the node, but after processing application, after work of control layer, all nodes all nodes which which is used for this pocket transmission or this flow transmission, already know what to do. So we come from just one pocket transmission to flow transmission because it is this solution is not only for one pocket, it's for some group of the pockets which have the same marker of the flow. So it works something like this. So actually, except of the routing, as I said, application can calculate, can collect information for for monitoring system, for monitoring all nodes, how it work, how to find best path um, for the floors, for find best solution. So it is as when we have information, we can use it for better for increasing of the increasing quality of the services. As also it can be this application can process some security services, some some cyber security protocols or some elements who help to process to um, protect the network from different attack. So it is main idea of the software-defined network. Do you have question about these pictures? Okay, if you don't, then we can note some specific for this no, for the specific characteristic of SDN. First of all, is they are directly programmable. So network control is use network control is directly programmable. So you can program it as you wish, as you need for your tasks or for your system tasks. It's and this programmable features is divided from forwarding function. So for function we connected with data transmission. Again, it's abstracting control from forwarding lets administrator dynamically adjust network-wide traffic flows to meet changing needs. How it works? Actually, I have to say that control layer, it means control layer for not for only one node or for 3 nodes. It's another for sure it is we can't say that one controller is used for all networks or for one controller for whole Ukraine networks. It's not true because for sure control is for some controller is used for some segment of the network, and then maybe different controllers used for grouped is grouped for some more no big controller of controller. It's also works. But this concept of division control layer and data layer, forwarding layer, forwarding function gives us to inform, to organize the best path, the best quality of service on the programmable level. So software calculate better, faster, and lots of nodes will know how it works at the same time. So we not need to calculate some routing function on each node because we send to the cloud, to the control layer calculate and inform all nodes on the path. It's very useful. Centrally manages the send also. So we deal with some locally centralized system, software controllers then maintained in a global network which appears to application and policies engines as a single. So we have to from one side, with this connection, physical node with controller. From other side, controller is cover different nodes and it helps to manage larger systems for this. Then the programmatically configured SDN lets network managers configure, secure, and optimize network resources very quickly via dynamic and automated SDN programs. So different tasks can be solved by application, and this application work faster and gives better result for the system. Open standard-based and vendor neutral. What does it mean? It means that actually then helps the system to helps give some dependency from the vendors because vendor can give no so he for managing its equipment it can ask more because you all have already bought the equipment and you have to buy these programs or some some new version of the program files. But when we talk about SDN, then software-defined network application, it can be very different, and it gives possibility to come into the different new company can propose its applications, and this application can be used for so independently on vendors requirements. According to how does SDN work, you can see that we have some we have some nodes and we have some controllers which cover different nodes and group of nodes. And when first I told about this, first request in coming to the node doesn't know information about this node, then it sent it send request to the controller. Controller send request to application. Application calculate the best solution. Then application send this solution even not only on this controller, it sends solution to also for other controllers, and this controller which is involved in this red line path, all nodes will know what to do after this calculation. So first one send request to controller, controller send request to application, application calculate, and then send response on group of controllers who take part on this path. So it's very useful, very fast connected, comparing with when each node have to know what to do the next. And also it's all of us to find better solution, the best solution, because all the very chance in each path we have to find, but not on this. So fast solution, scalable solution, quite easy solution. According to software controller and how it works, how it even not only controller is just this network controller software. So the main idea is fast recognize request of this controller, which request I mean. All requests is sent, so forwarding node, it's connect with control plan with protocol open flow protocol. So it asks the flow vision, and then it's use different controllers. Actually, OpenDale, it's here. We'll speak. Maybe not. I talk a little. If you not some lecture, some materials we can continue tomorrow because we have 2 minutes. So control plan ask with control open flow protocol, send request to controller recognize this request, and then send it calls southbound API, so API between controller and nodes, forwarding nodes, and northbound API, which organize connection between controller and application. So it is also it's another type of request. So actually, controller have to make this functionality, have to receive, understand for which application this request have to be sent to it, and then come back and so on. So it's in general SDN controller system. Also, you have some slides where it is no, from where this pictures was taken. Okay, thank you very much for today. Do you have questions to me? Okay. Thank you. Sorry for delay. I hope it was interesting for you and it wasn't so hard for you. Okay. Uh, thank you. Thank you very much. See you next Thursday.
Yes,
Thank you.
you.
Bye.
Goodbye.
Bye.
Bye bye.